Hello children. So this video will help you to understand the rest of the part of group 16 elements. In the previous video we had already discussed about the reactivity towards hydrogen. So here in this video we'll be talking about reactivity towards halogen. And basically very important questions are based on tetrafluorides. We have also learned this concept in grade 11 about SF4, SEF4 and TEF4. What you need to keep in mind is about hybridization. So it is sp3d. Shape is trigonal bipyramidal, which we are already aware, but its geometry changes to seesaw shape. Very, very important point, because it has only the central metal atom, that is sulfur, has 4 coordinating atoms. So this is the sulfur central metal atom. It has 4 coordinating fluorine atoms and one of the equatorial site. We already know that in trigonal bipyramidal shape, these 3 fluorines, here if it would have been, but here it is not. So these 2 fluorine and the lone pair forms an equatorial position, whereas these 2 fluorines form an axial bonds, right? So in this particular structure, since we lack one fluorine atom, because trigonal bipyramidal shape stands for 5. How 5? 3 plus 1 4 plus 1 5. 5 orbitals, but we have only 4 coordinating atoms. So the left of position is taken by lone pair of electrons. Therefore, its geometry is not same as the shape. It flips to seesaw. Understood? So that's very, very important point to understand and equally important for the board exam. So let us go ahead. So let me just take a marker for you so you can easily understand. Okay. So now we are going to talk about dioxygen. Okay, because oxygen was the first member of this group, and we had already discussed about the anomalous behavior. It had a small size, it has high electronegativity, and it has absence of d orbital. So all these points we have already discussed in the previous video. So here we need to understand that oxygen does not react with platinum, Pt, gold, Au and noble gases. That's very important question. So they can ask you which are the elements with which oxygen doesn't react. So these are the 3. And here I have mentioned clearly all the reactions with which oxygen is showing a behavior, positive behavior, and it reacts with few elements as well as compounds. You can see here very well, and following other products. So please learn all these reactions. Strictly saying, a lot of questions will be asked to complete the reactions. So they will give you the reactants and put a question mark on the product side, and you need to fill in. So these reactions are not difficult, just go through it. You have been learning, it's a simple oxidation reaction. So all the elements are getting converted to their oxides. Okay, so we'll go ahead. Now, very important reaction to support the nature of the oxides. Although we are discussing about non-metals, but in this particular topic, they have discussed about the metallic character, the non-metallic character, as well as the amphoteric character of the oxides. So we already have an awareness that all metals form basic oxides, wherein all non-metals form acidic oxides, and there are few elements, that is metalloids, which form amphoteric oxides, right? This all we have learned in our previous class, grade 11. So how do you satisfy the acidic nature of non-metallic oxide? Let us just understand. So any non-metallic oxide, let us take an example of sulfur dioxide. When it reacts with water, it should give you an acid. Yes, it gave us an acid. Hence, it's an acidic in nature. Whereas we have also learned that all metallic oxides are basic. So CaO is a metallic oxide which reacts with water to give you a base. Hence, it supports its basic character. Okay, And when I talk about aluminium Al2O3, that is aluminium oxide, has an amphoteric character. That means it can behave both as an acidic oxide as well as basic oxide. So let us understand this. Let me just set it for you. Okay, now here you can see in these two reactions, it's very well evident that aluminium oxide, when reacts with an acid like HCl, of course, because since we are talking about a solution, so we have to take water in it, and you're going to get a complex. To understand better the complex, we're going to get into the chapter, maybe chapter 9. Yes, that will be taken. After this, I'll talk about D block, and then I'll be talking about coordination chemistry. So in chapter 9, that is coordination chemistry, we'll be learning about these complexes. So I'll just give you a little idea that here you can see water, right? H2O. So H2O are basically ligands. There is a term called as ligand which coordinates with the central metal atom aluminium, and you get a complex. So you have to memorize this equation. They do ask in board exam. The next very important question is, since we are talking about amphoteric nature of aluminium oxide, so if it's basic, it should react, right? If it's acidic, it should also react. So when aluminium oxide was acting as a base, it reacted with acid. Here it is acting as an acidic oxide, so it's reacting with a base. So when it reacts with the base, that is NaOH along aqueous solution, again you get a complex. So all these reactions, please do memorize. Next important board question is ozone. What is ozone basically? Ozone is O3 molecule. So when oxygen, dioxygen reacts with nascent oxygen, it would give you ozone. That's O3. So why is ozone thermodynamically unstable? Why do we call it as unstable molecule? Because ozone has an ability to immediately decompose. As I said, it is made up of oxygen plus nascent oxygen. Oxygen means dioxygen, right? Dioxygen plus nascent oxygen. But it's not a very much stable compound. It will immediately decompose to give you nascent oxygen as well as dioxygen with lot of heat. So it's a highly exothermic reaction. So since it is highly exothermic reaction, therefore the value of enthalpy will be negative, right? So delta H is negative, and entropy will also increase because we are getting a gas, and the gaseous state is the most unstable state. There is a lot of agitation, so hence entropy is positive. And we also know Gibbs Helmholtz equation, which we have learned in grade 11. So based on that, the delta G value will always land up as negative. Hence the reaction is very much spontaneous. It's a very, very important board question. Please make a note of it. Okay, so I hope all this is clear to you. So do note all these important points and go for these FAQs as well. Let me just set another page for you. Okay, so here we go. Let me take a marker. Okay, yeah, here we have set. Fine, so now we are going to talk about ozone. Next important thing is ozone acts as a powerful oxidizing agent. Why does it act as an oxidizing agent? Because previously we learned that it liberates nascent oxygen, and these are the two reactions which support its oxidizing nature. So in this first reaction, if you can see the lead, right, lead sulfide, when it undergoes reaction with ozone, it is going to give you lead sulfate. Hence lead got oxidized, and ozone again decomposes or reduces itself to oxygen. In another reaction, iodide ions, I minus. These iodide ions we have got from Ki, that is potassium iodide. So when potassium iodide sample is allowed to react with ozone, again this I minus is going to get oxidized to iodine, and ozone itself gets reduced to oxygen. So these two reactions support the oxidizing nature of ozone, and these are very very important reaction. Based on this, the second reaction, you have another important question: how to estimate ozone quantitatively. That means if I want to know that in this particular reaction, what's the amount of ozone gas used up, so this can be found by the process of titration, right? We all are aware what is titration. So since it is very much evident in the second reaction that I minus, that is the iodide ions, have what? Oxidized, correct. They have got oxidized to iodine, and this iodine can be titrated with hyposolution. What's hypo? That you need to understand. It's also known as sodium thiosulfate solution. This is a formula which you should keep in mind. So when you titrate it, you come to know that how much of oxygen was being used up in this particular reaction. So we move ahead. So the next two important points are about resonance of ozone molecule. So resonance, resonance shows that both the bonds between two oxygen atoms are same. So since those two bonds are same, therefore we say it is because of resonance. And you need to learn here their bond length, the shape is angular, and as well as the bond angle, that is 107 degree. Okay, another same thing is about SO2 molecule. In SO2 molecule also, it's very very important question what they ask usually is about reducing character. So SO2 molecule has a reducing action. That means it is acting as a reducing agent, wherein ozone was acting as an oxidizing agent. So these two reactions support its reducing character. As you can see here, ferric ions have been reduced to ferrous, and sulfur dioxide has been oxidized to sulfate ion. Likewise here MnO4, that is manganate. You have heard about potassium permanganate? Yes. So MnO4 ions have been extracted from potassium permanganate. Again, it shows its reaction with sulfur dioxide. Sulfur dioxide reduces this to manganese ion, Mn plus 2, and itself again it gets oxidized to sulfate. And please refer the textbook page number 189 and learn all the structures of oxo acids of sulfur, because surely you get a question in board exam. So here that's all about this topic, and we'll see you in the next video. If you have any doubt, please feel free to call me, ask me, or you can WhatsApp me for any doubts. And again, FAQs are already being sent to your mail. Please do learn. Thank you.